can start with that.
Okay, my name is Inju Snyder and I teach mathematics in Fletcher High School. For me to come to this RET 2022 has been a great experience. As a math teacher, I felt like I was a child left in some space that I could not figure out the survival thing in general. So anyhow, when I went to Dr. Sprov's lab, they were keep on talking about crystals, making crystals, and so I asked what they're doing. The main headline of Dr. Sprov's lab, his paper was this. He's going to make a crystal to make it better luminescent, and it's going to be better long-lasting, and it's going to have some way of application to even embed that in a security system. So I am going to show you some of the pictures that I kind of got. Why do I have to have a better solar materials? Because it happens. More than any other area, Dr. Sprov's lab is focusing on the solar material for the space industry because they have to carry it over there. It needs to be lighter. Since it's going to be there, transportation is difficult, so it should last longer and should be brighter. So that's one of the reasons they are doing that for their application. The other is, as you can see over here, so many of you now know the virtual museums, and they require huge screens that are composition of the LED lights behind. So they are going for cheaper materials and brighter materials. And also on here in this picture, it shows the fingerprintings. Now, in the past, if you see other dramas or investigative films, you can see they brush something off. But now by applying the light, they can see those images of the fingerprints if it has those crystal materials in it. To touch some objects, if you touch it, if it has those crystal material in it, you can just shine the light and they can see the picture of the fingerprints. So that is the reason they are going for this research. So the goal for this lab is to discover brighter and stronger metal halide crystals, and also better coating materials for the solar panels and those fingerprint industry. So I remember that we had 3 significant researches. So first experiment I got involved in is making potassium copper bromide, and those are for the crystal LED lights and also fingerprints, and we had to go through combining the chemicals in the glow box. Then we will grow them. As you can see in this beaker, you can see the crystals. It's in the beaker, so we have to extract it, going through a different process. And when you extract it, that's the beautiful image of crystal. And from that crystal, you're going to go under different lights, UV lights, and also you're going to show that through the spectrometers, and you can see all the other things. So I put these pictures in there because there is some differentiation between these two. This is still cesium. That was a little different material, but that shows that why fingerprinting is so critical, and it's their interest developing these crystals. So once we extracted the crystal, that picture shows how it luminescent or emit the light under UV light. And when I took the picture with my camera, which is Samsung, it looked very purple. But when Heather took that same picture, it was more blue. So we kind of asked, why is that so? So there is a line that different cameras take different picture of the image, whether it can absorb more UV lights or not. But when I saw it with my eyes, it looked like purple. So I asked, something's wrong with my eye? He said, you might see a little more range of the lights, is what my graduate student Tyler explained to me. So there's a spectrum of the light, and some can see over here, but some can see a little more like that. If you have a Samsung, that's what you want to see. If you have iPhones, you will see more of blue. And so these are the examples of crystals you have seen it under different lights. And with the material, you have to go through this machine. Poppy has been standing in front of that machine, and there's Poppy from our lab. She's comparing the data by putting those samples in a little tray, and she analyzed those graphs to figure out, does it excite the crystal at what point, or does it emit some light at some point? And she compares those data by looking at all kinds of graphs. So that was very interesting for me to see. And then Dr. Doug is the one who comes up with all the structures of the crystals when they make them. Send it to him, and he will say, well, this has certain character and it has this structure. And they have to go back and readjust it because, like I said at the very beginning, they want to make it to be stronger and it had to be brighter for the different application. So what I'm going to go back to the very beginning of the statement I had. This is the inorganic material. They are altering that to come up with a better compounds to emit better light, and it could last longer. So that is going to show up on my next experiment. Okay, let me go there. Oh, before I do that one, I'm going to talk about the solar cells. This is a cesium silver bromide. We are going to make the compounds, and in this experiment we had to make a little palette. It was like a 0.5 centimeters, which is 5 millimeters small, but to prepare the sample, because it is affected by the oxygen and also light, we had to seal it in the tube, and we are going to store it in the dark place. So this was very exciting for me to first see how I can cut the glass tube that was 4 foot long into 4 1 foot long tubes. So that was just to prepare the glass tubes for the sample that we are about to make. To make the sample, we had to be in the glove box, not just putting it together, but on the motor, we have to ground it so fine, so when I put it in this press and put it under the compressor, there should not be any air, because by tightening it so close, it will react to each other much better. So we had to store it in that. Then I did not use this compressor because our graduate students said it would be better for us to break it than the visitors. So Poppy was the one who had to press all these pallets. And when we get the pallets done, we put them in the tubes like this. And she said maybe we could put 10, but our daily production was not as good. We most made was 6 a day. So we sealed them and using the torch again. That was that experiment, and that will be sent to other places for the further experiment and testing. And this is the one that we did for Dr. Bum's office at UU, because he has this paper that he wanted to see how good the film, the coating would be. So we had to make the glass slide for that lab. And this is the formula that I got, and I felt so overwhelmed when I looked at it. So that is probably the reason I remember the name of it, because I had to say it over and over. Fomamidinium lead bromide chloride is the compound. And to prepare the compound, we first of all have to clean the glass slide. You have to put it in the sonicator, and you degas it and then let it sonicate, because the surface of the glass is so clean. And that is not enough. You have to put that through plasma cleaner. So you will remove all the tension on the glass slide. So when you apply the film on that, it will attach to it much better. So that was really cool. That glass slide we made went in that little place, and we kind of thought that was cool. It emits that particular light because it was a cleaning process. When we, after we got that done, we got the chemicals together, and we had to mix it and add solvent, and we went through, let the chemical go through the evaporator evaporate rotator. That's what it was called.
Yeah.
Yes. And so when it stayed overnight, the solvent and the chemical in this plastic became like powder-like. So we had to make the powder that way. And when we got the powder, actually now we are about to apply the chemical and solvent together in spin coat. This was in the glove box, and this was out in the open. We did two different ways of spin coating the glasses. And when we did in the glove box, we used a bigger glass, but then we realized that Dr. Baum wanted a much smaller one, and we had to cut all these glasses into small squares, and we had to go through all the process. But that was really, really exciting for me, because to me, that was like, that made me feel like I was in a kid in the candy store. So that was really good. Now, after that is done, we have used 1:3 ratio according to the paper, but even though they are all 1:3 ratio, we got the best film coating result when it was 150 for the solution we made and methyl acetate. So that was quite an interesting finding, because we didn't know which combination will produce the best film. So that film is sent to Dr. Baum, and I asked Tyler if he heard from him. He said no, he hasn't. So through this experience, what are they doing next step? They're going to further and develop better and stronger and brighter LED lights, and also those films that they are doing such a great job with. So hopefully they are going to have some big business to join them and try to use the technology and the crystal they are developing pretty soon. And here is my thanks to everyone, including everyone in this classroom. And these are us, right? Go RET 2022. I'm so proud of every one of you, and Dr. Nanny, Dr. Tessman, Dr. Saprov, and everyone who was at the lab was so very patient and kind and explained to me everything like they heard it from some intelligent person, when I didn't feel that way at all with a master's degree there. But thank you again for this opportunity. It was great that I am going to take this experience with me to my students and share it with them whenever I can. And thank you. No questions. Do we have any questions? All right, good.